If x and y are integers and 2x negative y equals 11, then 4x plus y cannot be which of these options that we have here? That's the question that we're told to find the solution for. Now, looking at the question we have here, we are given two hypotheses, that is two assumptions. So the first assumption we are given here is, it says if x and y are integers. So that's the first assumption, x and y must be integers. Then the next one is x and y, they satisfy this equation here, that is 2 times x negative y equals 11. And that is the second assumption. Now, based on these two assumptions, we are told that 4x plus y cannot be which of these? To make this whole work simpler, now the thing is, I want you to be aware that there are different ways or different methods or techniques that you can go about finding the solution to this problem. But I'm going to show you the way I think is best to quickly find a solution to this. Because the thing is, it's not just finding the solution, but being very effective with time. That's the most important thing. So you have it says 4x plus y cannot be what? Now what you observe here is you have two options here. So the first you have is you have two variables here, sorry. You have x, you have y. Now to make the work simpler, I want to try and see if I can reduce 4x plus y into an equation that has just one variable and then begin to check based on this. So what I'm saying is going to become clearer when I begin to start solving this problem. Alright, so what I have here is 2x negative y equals 11. So what I'm given is, I'm told that 2x negative y equals 11. This is what I'm told. So I want to solve for y here. So to solve for y here, my y is just going to be, so we have y here, y comes here, and then 11 comes to this side. So you're going to have 2x negative 11. So my y is 2x negative 11. So if my y is 2x negative 11, then let me find 4x plus y. So my 4x plus y, let me just write my y like this. So this is my y. So my y, this is going to be 4x plus, so the y I obtained there is 2x negative 11. And then this is just going to be 4x plus 2x is 6x negative 11. So another way of writing 4x plus y is just 6x negative 11. So in other words, this question just simply implies that if x and y are integers and 2x negative y equals 11, then 6x negative 11 cannot be which of these now? So now note, we obtained 6x minus 11 just based on the information we have here. We have not used the fact that x and y are integers, that is, x and y are whole numbers. Now let me begin to do this. It says then 6x negative 11 cannot be which of them. So I'm going to test each of these options one by each. I would assume 6x negative 11 equals negative 5, and then I would solve for x. When I solve for x, so you recall we were told that x and y must be whole numbers. So considering option A says, so if x equals, let me just pull an arrow. So I'm going to test this for this. I'm going to test 6x negative 11 for this. I'll test 6x negative 11 for this, and also for this. So assuming 6x negative 11 equals negative 5. So it says it cannot be what? So I'm assuming it is this. So I want to solve for x. So let me solve for x here. So when you solve for x, you add 11 to both sides. So you have 6x equals, so it's going to be negative 5 plus 11. So you have 6x equals negative 5 plus 11. That is going to give you 6. So to find x, you divide both sides by 6, and then you obtain your x to be 1. So x is an integer. X equals 1. That's what you have. So x is an integer. So A passes. So I'm going to B. Now for the B part, we have 6x negative 11 equals, so assuming this equals 1 now, this equals 1. So if this equals 1, so I want to solve for x. That's what I want to solve for. So what you have here is going to be 6x equals, so this is negative 11 comes here, it comes 1 plus 11. So you have 6x equals 12. So to solve for x, we divide by 6. We divide by 6. So this goes off, and then we have 2. So that means our x equals 2. So this is also an integer. This is a whole number. So that means B passes. So let's go to C. So for the C part, when 6x negative 11 equals 13, so you have 6x negative 11 equals 13. So to solve for x, so we add 11 to both sides, so you have 13 plus 11. So you have 6x equals 11 plus 13, that's 24. So to solve for x, we divide both sides by 6. So what you have here is going to be 4. So you have x equals 4. So again, when 6x minus 11, that is when 4x plus y equals 13, it satisfies that is x and y are still integers. So let's go to D. So the D part, so when 6x negative 11 equals 17, so I want to solve for x here. So to solve for x, again like we did, so you have 6x equals, so this becomes 17 plus 11, which is going to be 17 plus 11. So you have 6x equals 28. So to solve for x, you divide both sides by 6. So this goes off. So what you obtain is x equals 28 all over 6. So what you observe here is 2 here is 3, and then 2 here is 14. So your x here equals 14 all over 3. So but 14 all over 3 is not a whole number, because we're told that the assumption is x and y are integers. So that is, what you have here for your x must be a whole number, but this is not a whole number. So this is a contradiction. So that tells us that D does not satisfy the fact that that is 4x plus y cannot be D. So now just for verification's sake, you can as well do E to check that out. So let's see. That's for the E part. So if you have 4x plus y, sorry, do I need to write 4x plus y? We already know 4x plus y is the same thing as 6x negative 11. So you have 6x negative 11. If it equaled 55, so 6x is going to be 55 plus 11. So 55 plus 11 is that is 66. So 6x equals 66. So to solve for x, I have to divide both sides by 6. So this goes off, and then you obtain your x to be 11, which is also an integer. So that tells us that the option D, which is 17, is the only one that doesn't make these assumptions that we have here to be valid, and that completes the problem. Thanks for watching.